Welcome, everybody. We're going to be working on the second half of the chapter 3 exercises tonight. The first one we're going to tackle is exercise 314, which you can see on the screen here. And basically it says, write a program that takes user input describing a playing card in the following shorthand notation. Okay. So if you got an ace, you use the letter A. If you have the numbered cards, you use the numbers 2 through 10. And by the way, whenever you're in a coding book and you see ... that means there's other stuff in here, but we're not putting it all there, right? So that implies 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? Those are the numbered cards in a deck. Then we have Jack, Queen, King. And then we also have designations for diamonds, hearts, spades, and clubs. So for example, your program should print the full description of the card. So you would enter the card notation, for example, QS, which means Queen of Spades. So you need to be able to accept this input and then convert it into that, right? And mind you, we're not playing blackjack or poker here or rummy or anything like that, right? We're just taking the notation and turning it into the words. And this is more practice on our decision statements, right? The fascinating thing about doing real world situations and applying them to coding is you have a model to work from. And I always tell my students that this is really conceptually important, right? So like if I think I use the example of like rock, paper, scissors and the 5-year-olds, like kind of explaining the rules in like 5 minutes. A deck of cards is a really interesting kind of structure to study. And it always amazes me that there are people, and I happen to know a few of these people that are like whizzes at playing cards, and they go to Vegas and they win money, because they're good at like counting the cards and keeping all that stuff in their memory. But there's also all these weird algorithms that go with it, because you don't have like 10 cards in a suit. How many cards do you have in a suit? You have 13. That's
13.
yeah, right. It's a weird number to calculate, right? It's not like a dozen or 10 or 6 or 5 or something. 13 is a weird number to do math with. You also have this thing where some of the cards might have multiple values. Like you have the royal cards, and then you have the ace, which could be a 1 or is it an 11, depending on what game you're playing. So there's all these like weird things. Couple that with the fact that you have the 13 cards across 4 different suits, right? Yeah. So it creates a lot of really interesting coding scenarios. This is a pretty simplistic one, because really what we're doing is we're converting the letters in the left column to the names on the right hand side, right? That's basically the goal of this program. The first thing that we have to do is prompt our user to bring this information or type in this information into the program. All right, so let's start by getting some user input then. And I'm just going to do this in this fashion. All right, so yeah, I'm copy pasting, but I'm going to prompt our user and I'm going to say, enter the card notation. And, trying to be polite, please use all caps, right? And of course, a lot of people won't, right? But notice what I'm doing in the second statement is I'm taking whatever they put in and I'm converting it to uppercase. And I think we mentioned last week, another way to accomplish that is I could just do dot upper here like that. And that works too. And generally speaking, experienced programmers would take that approach. I like to put them in separate steps at this level so that you can see them as discrete actions, because they really are. Okay, so getting the input, just in case they didn't type uppercase, we're changing it to uppercase for them. And then that makes the code that I write a lot easier to determine. All right. So we did this whole thing last time, and I don't know if you guys recall this, where when we have a user typing in basically a string at the keyboard and then they press enter. In this particular situation, we are going to have them type probably 2 digits. And if you guys remember, whenever somebody types in a string, what happens is the first character position is known as position 0. The second character position is known as position 1. And if there was a third position, it'd be known as position 2. In every scenario, except for 4, they're going to type 2 digits or 2 characters, like Queen of Spades or Ace of Hearts, like AH, right? But there's one scenario in each one of the suits where we type 3 characters. And that is when they type the 10 card in. So for example, I would type 10 of diamonds or 10D. So you see what the challenge is here, right? All right. So in most scenarios, we're only looking at 2 of the characters, but there's 4 scenarios out of 52 that we're looking at 3. So we're still going to use those index numbers like we did last time. And so, all right, so this creates kind of like some interesting challenges for us. And what I usually like to tell people is, first, let's figure out the numeric value of the card, right? And the way I'm going to do that is whatever the person typed in here, I don't want to alter it, right? So I want to take that, whatever they typed, and I'm looking now at the first position. So I'm going to have you do a consideration. If they're typing in a numbered card, right, using this notation, so the individual card and then the suit. If they're typing in a numbered card, it could be anything from 2 to 10. The number 1's not included. I don't know if you're feeling where I'm going with this, right? So normally think of like, oh, we go from 1 to 10, but here we're going from 2 to 10, and the ace is really 1, and the only numbered card that starts with the number 1 is the 10 card. So I don't even need to look at the second digit to determine it's the 10 card. You guys feel what I'm saying? Right? Because if I type in 1, it's not an ace because I would type an A for ace. So I only have to look at the first digit. So here's how I'm going to do that. I'm going to set up a new variable and I'm just going to call it value. Okay. What am I going to put in there? I'm going to look at whatever they typed for the card, and then I'm going to use that index value to grab whatever character is in the first position. Doesn't matter if it's ace, queen, king, jack, whatever, or a number. The numbers are going to go from 2 all the way up to 9 and then include 1. So really 1 to 9. But if they type 1, it's a 10, right? And then I did this last time. I'm just dropping in kind of my logic. And I started last time typing this because, and I wrote, if the value equals 1, from in that first position, we'll just make it 10, right? But I'm not going to put this here, right? So I'm going to move it below and I'll show you what I'm going to do. Now I'm going to write a grand if statement that covers all the scenarios for the numbered cards only, right? This is all we're concerned with right now is the numbered cards. So I'm going to say if the value is equivalent to 2, and I want you guys to be really careful here. I'm not converting what they type at the keyboard up here to an integer. I'm not doing that. I'm treating it as a character, so I'm checking it as a character inside double quotes. I don't care if it's a number. It doesn't matter, right? To them, it's a number. To me, it's a character, all right? So if that first character is a 2, then the value that we're going to put back up on the screen is going to be the word 2. All right, makes sense. All right, now we have a roadmap. So now I can say else if, right, ELIF, the value is equivalent to 3, then value will be changed to the word 3. Okay, I want you to notice something, and maybe you're not picking up on this yet, right? So like, especially those people that have worked in another language, If I was doing this in Java, I would not name my variables this way at all. I would not. I whatever I'm naming it, I would have a different one like called like card name or something. But here I'm taking like what was in there and I'm changing it from a number, well, what looks like a number, it's really a character, to a different word, but it's basically the same number as a word. But I'm putting it back in the same variable. Weird. That is very weird. Not normal compared to other languages, by the way. But in Python, totally acceptable. Right. Welcome to Python, folks. Now, it doesn't take a genius to figure out the pattern here, right? So if you've already kind of picked up as to where we're going, what you should do is really kind of do this, right? Just paste it in a whole bunch of times and fix the numbers, something like that. And then just go one by one, very methodically. And so 4 will be 4, 5 will be 5. And yes, I'm saying it all out loud because it will take you guys a little bit to type it in, but it builds character to do so. Not really. All right, I pasted too many times because now I'm getting to the 10 situation. And it looks like I have one too many here. So I'm going to just kind of get rid of this extra one. But that last one, which is actually 10, I'm just checking the first digit, and the first digit is 1. Then they must have typed 10 because there's no other card that has a 1 in it. So it's 10. What if they don't have a number in the first position? Okay, well, do I need to do anything? Okay, so some people argue, no, you don't need to do anything, right? Because what if they type, because if they type number in the first position, it's going to be one of these numbers. What number are we not including? 0, right? So this potentially could type a different number. Okay, so I'm going to put in an else. And here's my else. There's no checking on this one. I'm just going to say value equals, I don't know, error. I don't know if this condition will ever hit, but I'm just kind of thinking about it. Back over to the margin and scrolling down. All right, so that's complicated, long if statement to take the first character of the card, process it in this if statement, and come up with the first part of the statement. 2 of clubs, 3 of diamonds, 4 of hearts, etc. That's part 1. Right. Right now, all we're storing is the name of what value the card is, if it's a number, right? All right. Another thing that eventually we're going to have to capture is, and we should probably write this down, we need to capture the suit of the card. And don't worry about the ace, king, queen, king, jack stuff. We're getting to that, right? All right, we're going to capture the suit of the card. So I'm going to come up with another variable. I'm just going to call it suit. And now I got to figure out a way to determine, this is where it gets tricky. All right, so I'm going to pull up my friend Excel here once again to kind of demonstrate this point. Right, if you guys remember what I did last time, and this is like goofy, nerdy demonstration of characters and actually we're going to merge those 3 cells. I'm going to draw borders on all of it so you can see it. And I'm going to zoom in even more. And the variable name that we're dealing with is value, which is holding a string. These are the index numbers, 0, 1, oops, I keep hitting that wrong key there, and 2. I'm going to center all the content so it looks nice, right? So those are my index values. And then these are like the letters. So for example, somebody might type 2 of spades, 2S. Another scenario, they might type ace of diamonds. But then you have that weird scenario where they type 10, right? And they're not going to put both, right? Because individual characters can only go in these spots. They're going to type 10 of hearts, and that goes in position 2. Now I got to write a really clever little way to extract this piece of information, regardless of if it sits here or here. This is kind of an interesting conundrum. If we could throw out that 10 card and only have cards that have one letter description, right? I wouldn't have this issue, but I do have this issue. So I have to figure out a code way to say, well, I want the character that's in the last position, regardless of if it's 2 characters long or 3 characters long. So here's kind of the way to do it. So normally, if I'm looking at this position, I would address it by saying value, oops, position 0, right? But this is, we did this last week, but we're going to reinforce this stuff because this stuff is important, right? If I want something in the second position, I would say value square brackets 1, not curly, square brackets 1, right? And that gives me that. And then if I want whatever's in the last position, okay, right, you're going to say, oh, okay, you can use 2. But really, to get the last position, here's the trick. I can look at the length function. So I can look at the length of value. And in this case, it's going to give me the value of 3. Now, I want you to notice there is no 3. But if I take the length, I can type it, length of value, which is 3, and subtract 1 from it, that will give me position 2. But if I did this, if I said ace of spades, the length is 2, right? So I'm going to say equals 2. Therefore, this would point to position 1 and still give me the last digit. See the cleverness of this? So I take whatever the length is and I subtract 1 and I have the correct index value. So back to coding, right? So to determine the suit, I will take whatever's in the card, right? Which is, okay, so I use the square brackets because I'm grabbing the position. I'm taking the length of card and subtracting 1. That will give me whatever is in that last position, right? Keeping in mind, card is whatever they typed in. So that will give me the suit as a singular letter. Spades, hearts, diamonds, or clubs, right? Now that I have that letter, now I can check for that one. All right, so here comes the code for that. And basically we're doing this. We're going to determine the name of the royal card and the ace, right? The suit will get sorted out later, right? So, and I'll show you what I mean by that. Right. Let's do, let's start with a jack. I mean, that jack, queen, king, that makes kind of sense to me. So I'm going to say if the value is equal to, equivalent to, right? So you see that like verbal training, to J for Jack. Then we're going to kind of use the pattern from above, value. And this is where I'm going to waffle a little bit. All right. So up here, I just said value. Okay, that's fine. But now what I really want to do is I want to take the value. Okay, and am I using the right name here? This is where it gets kind of interesting because I want to display the value of the card plus whatever, like if it's ace, queen, king, plus the suit and combine them all into one name. You guys feel where I'm going with this? Maybe, maybe not. All right. So let me just show you how I'm going to do this. I'm going to come up with a new variable name. I'm calling it full name, the full name of the card. All right. For J, I'm just going to put in Jack. Okay. Let's go with a capital J on that. And then, of course, I think you can figure out the pattern pretty quickly. So if the value is equivalent to Q, then the full name equals queen. Else if the value is equivalent to K, there's our colon, the full name will be set to king. And then, of course, we do have the ace scenario. So let's get an ELIF in there for that. And we say if the value is equivalent to A, then full name is going to be ace. Do we have any other scenarios to worry about? Well, okay. Here's what's getting kind of weird about this. Well, if you think about it, it's going to be like either a numeric card of spades or a royal card of spades. So there is an else here, and the else is going to be if it's none of these, then the full name is going to be equal to the value we already determined up here. That's one way to do it. Okay, another clever way to do it is we could just set all of these to be full name, and then I don't have to do this line. That's another way to do it. That there's no right or wrong there. This is just the way I'm choosing to do it. So if it's not a royal card, it's going to be one of these. It's set right here. All right. Now we're going to move forward here, making some blank lines. All right. Now we're going to take whatever we've come up with as a full name so far and add or concatenate, right? Space of space. So in other words, queen space of space, and it's ready for the suit. You feel where I'm going with it? And I'm concatenating it, or in other words, adding strings together, joining strings. So whatever this says, king, ace, 2, 10, whatever of, and then it's just waiting for the suit. Another way that you can accomplish it, and I'll put this on the screen too, right? And we saw this last week with doing numbers, right? Is you can use what we call, kind of like concatenation in place. So this symbol here works with math, but it also works with concatenation. So I can take full name and plus equals or concatenate, because it's a string, space of space to it. Clever, right? Maybe you guys don't see it as clever, and if you want, just to prove to you that it works either way, and actually the arrow should go the other direction, right? That way. But those are functionally equivalent statements. Right, now we're going to determine the suit. Once again, I'm adding some blank lines here. And once we determine the suit, then we will concatenate the suit name to the end of the string, and it'll be like ace of spades. All right, so here comes the code for that. Another series of if statements. If the suit that we determined above is equivalent to the letter S, right? Then the full name, and I'm going to do it both ways here, by the way. I'll just do full name plus spades, else if the suit is equivalent to, what would come next? H, hearts. And this one I'll do plus equals, same difference, right? But I'm just going to say hearts. But you can see like why this is easier than doing that. Right, functionally kind of the same. And then, of course, once you have your pattern set, then it becomes pretty mechanical to change it. So we can do clubs. And D. Is there an else in this scenario? Yeah, they could mistype it. So they might not type a S, H, C, or D. They might type a Z, right? And so we need something to accommodate for that. So I'm just going to put in an else and say full name. And then we're just going to put in an error message because really the whole thing is flawed then. And we'll say, we got to put quotes around it. Error. No such, oops, suit exists. Hopefully nobody caught that mistake. It was innocent. I really was very innocent. Just a mistype. Check what you typed. Try again. Something like that, right? Give them a message that what they typed in is incorrect. Right, so that's my else. Then we're at the bottom. This is all the logic, folks. Now all we have to do is display the output, and all we have to do is output the full name, and we are done. There's nothing else to do. Okay, I'm doing a Control S to save. We'll do a run, test it, and then take a break. I know that I was going to take a break before, but I didn't want to stop because I was on a roll. All right, let's give it a run and see if it works. Enter the card notation. All right. So first thing I'm going to do is I'm going to use lowercase letters to make sure it works. So I'm going to do A-S. Error of spades. Uh-oh. So something isn't working right. Why is it giving me error of spades?
Else. Error from the else. Bottom the first if.
Yeah, it is, right? Because it's not any of these. So here's the question then. Do I need this statement? This is the, if I remove this statement and try it again, AS. Interesting, right? You guys thought I was being dumb before. It's really to kind of like walk us down a path and see an example. I don't have to have an else. If none of the conditions hit, none of the conditions hit. Simple. Doesn't matter. Okay. All right. So, all right, we tested one scenario. Let's try some numbers. How about 1H? Oops, my numlock is off. 1H, lowercase again, because of course I try to break it. 10 of hearts. Now, this is wrong also. You guys catching where I'm at with this? Could we code around it? The answer is yes. You could code around it. So I could write a really complicated if statement that if a person type just one H or one and not a 3-digit thing, that we could exclude it. I'm not going to bother with that, real frankly. That's a lot of extra coding. But I'm trying to make a point, right? So all right. So let's try to be more proper now. Let's do 2D, 2 of diamonds, 3C, 3 of clubs. Let's try some royal cards, right? How about Jack D, Jack of diamonds? How about King of, I don't know, spades? Let's try to break it. Oops. Now, is that technically correct? Yeah. There's some issues with this, right? So, and this is where programming gets really persnickety, because you solve a bunch of problems and then you create other ones, right? And if I really wanted to be perfect about this, I would solve those problems. I'm not really super worried about that. Generally, the program is working. So if you've done what I've done, I'm happy with the result. A lot of stuff that we learned here, by the way. All right. Why don't we pause for a little bit here? We need a break.